Welcome to my YouTube channel known as Science Maths with Brother J. Here we have the equation which is in the form of radical forms. Now we are told to find the value of y. So here we are going to use the laws of exponents and the laws of radicals in order to solve for y. Okay. In our case, we are going to deal with the right-hand side. So here, we are going to use this law, the law of exponent, which is dealing with negative exponents. A power negative n equals to 1 over a raised to exponent n. The same applies. A power negative 1 equals to 1 over a. In our case here, let us copy the left hand side the way it is. The cube root of 20, the cube root of 3 raised to under root. Inside we have radical y plus 78. This is equals to 27 raised to power negative 1. Okay, let's go. Again, this side we can apply the rule of indices which are in the form of fraction, known as radicals. We know the cube root of a equals to a raised to 1 over 3. The rule of radicals says that the nth root of a, this is equals to a raised to 1 over n. So this law of radical will be applicable in this part. So here we have 3 raised to 1 over 3 under root. Inside the under root we have radical y plus 78. We know 27, this is 3 raised to power 3. In the bracket, raised to power negative 1. Okay, let's deal with the right hand side. Here we can also apply another law of exponent, which is a raised to m in the bracket raised to n. This is the same as to write a raised to m times n. So here we have 3 raised to 1 over 3 under root. Inside the under root we have radical y plus 78. This is equals to 3 times negative 1, we have negative 3. Here we can equate the exponents because here we have base 3, here we have base 3. The bases are equal. What you can do is to equate the exponents. So we have 1 over 3 under root radical y plus 78 equals to 3 negative. We have taken this exponent and then we equate with this exponent, which is negative 3. So here multiply by 3 both sides. We have 3 times 1 over 3 under root radical y plus 78 equals to negative 3 times 3. So here we remain with under root. Inside the under root we have radical y plus 78 equals to negative 9, because negative 3 times 3 is negative 9. Here, in order to remove the radical signs, take square both sides. Square both sides. We have under root. Inside the under root, radical y plus 78 in the bracket squared. Here we have negative 9 squared. Here we remain with root y plus 78. Negative 9 times negative 9 is 81. Then shift 78 to the right hand side. So here we remain with root y equals to 81 minus 78. Here we get radical y or root y equals to 3, because 81 minus 78, the answer is 3. So in order to get the value of y here, again square both sides. So we have root y squared equals to 3 squared. These two cancel with this, so we remain with y equals to 3 raised to exponent 2, which is 3 times 3. 3 times 3 is 9. So our answer is 9. Please don't forget to subscribe, like, and share my video. Thank you. Welcome to my YouTube channel known as Science Maths with Brother J. Here we have the exponential equation, which is 3 raised to power 2x plus 2 over 5 raised to 3 power y minus 6 equals to 30,375. So we are told to find the value of x and y. We can proceed as follows. So the left hand side expression can be written as 3 raised to power 2 x plus 2 times 1 over 5 raised to power 3y minus 6 equals to 30,375. Again here, we can use the law of exponent, which is a negative exponent. It states like this. A our negative 1 equals to 1 over a power n. We want to express this one, which is in this form, to this form by using this law of exponents. So we proceed as follows. We have 3 raised to 2x plus 2 times 5 raised to negative in the bracket negative in the bracket 3y minus 6 in the bracket equals to 30,375. So far we have expressed this one in this form by using the law of exponent, which is the negative exponents. So here, let's open the brackets, multiply negative 1 times 3y, negative 1 times negative 6. So we get 3 raised to 2x plus 2 times 5 raised to negative 3y plus 6 equals to 30,375. We know negative 1 times 3y, we get negative 3y. Negative 1 times negative 6, we get positive 6. Again here, what we can do is to express, we know 30,375 can be expressed as the product of 3 and 5 in this way. The whole divided by 5. By 3 first, we get 10,125. Again, divide by 3, we get 3,375. Divide by 3 again, we get 1,125. Divide by 3 again, we get 375. Divide by 3 again, we get 125. Here, 125 is not divisible by 3. It's not exactly divisible by 3. So now divide by 5. We get 25. Again, 25 divided by 5. We get 5. And lastly, 5 divided by 5, we get 1. As you can see here, we have 1, 2, 3, 4, 5. So here we can write 3 power 5. Here we have 1, 2, 3. We can write 5 power 3. So we have 3 raised to 2 power x plus 2 times 5 raised to power negative 3y plus 6. So 30,375 will be written as the product of 3 raised to power 5 times 5 raised to power 3. As you can see, this one, its base is 3, and this one, its base is 3. So we can compare this one with this one, equate this one with this one. So we have 3 raised to 2x plus 2 equals to 3 raised to power 5. Again, this one, its base is 5, and this one, its base is 5. So we can equate. And 5 raised to power negative 3y plus 6. This is equals to 5 raised to 3. As you can see here, the exponents are equal. Here the base are equal. Here we have base 3, and here we have base 3. The same applies to here. Here we have base 5, and here we have base 5. Now we can equate the exponents. We can equate the exponents since they have the same base. So here we have 2x plus 2 equals to 5, and negative 3y plus 6 equals to 3. Shift 2 to this side, we have 2x equals to 5 minus 2, and negative 3y equals to 3 minus 6. Shift 6 to that side to require negative sign. So we have 2x equals to 3, because 5 minus 2, the answer is 3, and negative 3y equals to negative 3. Not get x here, divided by 2 both sides. So we have 2x divided by 2 equals to 3 divided by 2. And again, this side divided by negative 3 both sides. We have negative 3y over negative 3 equals to negative 3y divided by negative 3y. Here we get x equals to 3/2 and y equals to 1. This is our answer. Please don't forget to subscribe, like, and share my video. Welcome to my YouTube channel known as Science Maths with Brother J. As you can see here, we have the exponential equation, which is 2 raised to power y equals to y raised to power 2. We're taught to find the value of y. Not to find the value of y, eliminate these exponents. So to start with, let us eliminate the exponent y. How do we eliminate the exponent y? We eliminate the exponent y by raising to both sides of the equation to the reciprocal or inverse of y. So here we have 2 raised to power y in the brackets raised to 1 over y equals to y raised to 2 in the bracket raised to 1 over y. This y cancel with this one, so we remain with in our case here we remain with y equals to y. In this case, we interchange the exponents. The one which is inside goes outside, the one which is outside goes inside. So we have y raised to 1 over y in the bracket raised to 2. Again here, let us eliminate the exponent 2. We are going to use the same method as the one we used to eliminate the exponent y. Here, we raise the inverse or reciprocal of 2 to both sides of the exponents. The inverse or reciprocal of 2 is 1 over 2. So we have 2 raised to 1 over 2 equals to y raised to exponent 1 over y in the brackets. We have 2 raised to the inverse of 2, which is 1 over 2. This 2 cancels this, so we remain with 2 raised to 1 over 2 equals to y raised to 1 over y. Here we can go extra mile or use manipulations. We know 2 is the same as write 2 power 1. So this one here can be written as follows, can be written as 2 raised to 2 over 2 in the bracket 1 over 2 equals to y raised to 1 over y. Here we can write 2 power 2 in the bracket. We have 2 here. We have taken the 2 which is above, that's this one. So here we remain with 1 over 2. So we have 1 over 2 times 1 over 2, which is this one. So here we have y raised to 1 over y. We know 2 raised to 2 is 4. A half times a half, we get 1 over 4, which is equal to y raised to 1 over y. As you can see, this one is in the form of a if a power 1 of a equals to b power 1 over b. It means that either 1 over a equals to 1 over b, or a equals to b. In our case here, we can just take 4 equals to y. 4 equals to y. Therefore, y equals to 4. This is our answer. Thank you for watching my video. Please don't forget to subscribe, like, and share my video. Thank you. Welcome to my YouTube channel known as Science Smart with Brother J. Here we have questions that we are told to find the value of y in 1 over y equals to 4 raised to power y. So in this case, in order to get the value of y, we are supposed to eliminate the exponent y. So how can we eliminate the exponent y? Raise both sides of the equation to the reciprocal or inverse of y, which is 1 over y. So we have 1 over y raised to 1 over y equals to 4 raised to power y in the bracket, again raised to 1 over y. We know this y cancel with this y, so we remain with 1 over y raised to 1 over y equals to 4. We know 4 is 2 times 2. So we have 1 over y raised to exponent 1 over y equals to, so instead of writing 4 here, we write 2 power 2, which is equal to 4. Again here, in order to get the value of y, we know if a raised to exponent a equals to b raised to exponent b, then a equals to b. As you can see in your question here, we have 1 over y raised to 1 over y. The base and the exponents are equal. The same applies to 2 raised to exponent 2. The base and the exponent are equal, meaning that this one resembles with this one. So therefore, 1 over y equals to 2. We equate either 1 over y equals to 2 or 1 over y base 1 over y equals to base 2. That is what I've written here. Put 1 here and then cross multiplication. We have y times 2, 2y. 1 times 1 is 1. So in order to get the value of y here, divide by 2 both sides. So we have 2y divided by 2 equals to 1 over 2. So therefore, y equals to 1 over 2. That is our answer. Welcome to my YouTube channel known as Science Master with Brother J. As you can see here, we have the exponential equation, which also contain quadratic expression. Now we are told to solve all other to find the value of y. In order to solve or to find the value of y, here, let us apply log to both sides of the equation. So applying log to both sides of the equation, we have log in the bracket 2y plus 7 in the bracket raised to the power y squared minus 4 in the bracket equals to log 1. So here, let us deal with the left-hand side of the equation. In order to deal with the left-hand side of the equation, here, let us apply the rule of logarithm, which is the power rule. It says that log b power n is equal to n log b. In our case here, the left-hand side expression resembles this expression. So we want to change this expression to this expression. We want to change this expression to this form by using this law of logarithm. Actually, as you can see here, the exponent here is n, but using this law, now the n has dropped backward. So the same applies to our case. Our exponent is y squared minus 4. So this exponent dropped backward. So we have y squared minus 4 in the bracket log in the bracket 2y plus 7 equals to log 1. Now let us deal with the right hand side of the expressions, that is log 1. We know, using the law of exponent, 1, this is the same as to write 10 power 0. By using this law of exponent, any number power 0, the answer is 1. So here, instead of writing 1, we have written 10 power 0. The question may be like this: why here 10 and not other numbers? We know when writing logarithm of a number to base 10, usually base 10 is left. It's not written. So here we have base 10. So log 10 power 0 can be written as log 10 raised to power 0 base 10. So we know log A raised to n base A. This is equals to n. So let us apply this law of logarithm in this case. In our case here, A is 10 and n is 0. So it means log 10 raised to 0 base 10. This is equals to 0. As we have said, log 1 equals to log 10 raised to 0 base 10, which is equal to 0. So here, instead of writing log 1, let us write 0 because log 1 equals to 0. So we have y squared minus 4 in the bracket log 2y plus 7 in the bracket equals to 0, because we have seen log 1 equals to 0. So here we can say either y squared minus 4 equals to 0, or log in the bracket 2y plus 7 in the bracket equals to 0. Shift this negative 4 to the right hand side. We have y squared equals to 4, or as I've said, here the base is 10, because when we write logarithm of a number to base 10, usually base 10 is left. So now let us include base 10 here. So we have 2y plus 7 base 10 equals to 0. Y squared under root plus or minus under root 4, or express this one in exponential form. We have 10 power 0 equals to 2y plus 7. Actually expressing logarithmic equation in exponential form. This one drops and this 0 rises. That's why we have 10 power 0 equals to 2y plus 7. Here we have y equals to plus or minus 2, or 10 power 0 equals to 1, which is equal to 2y plus 7. Y equals to plus or minus 2, or 1 minus 7. Shift this 7 to this side, equals to 2y. So we have y equals to plus or minus 2 or negative 6 equals to 2y. Rearrange, this one can be written as y equals to plus or minus 2 or 2y equals to negative 6. Rearranging, this one shifts to the left hand side while this one shifts to the right hand side. Again, y equals to plus or minus 2 or here divide by 2 both sides in order to get the value of y. So we have 2y divided by 2 equals to negative 6 divided by 2. So we get y equals to plus or minus 2 or y equals to negative 3. So we have got 3 values of y, which is y equals to either negative 2 or positive 2 or negative 3. These are values of y. Thank you for watching. Please don't forget to subscribe, like, and share my video. Welcome to my YouTube channel known as Science Math with Brother J. Please don't forget to subscribe, like, share my video, and turn on the notification bell. In so doing, you'll be the first to get my video once will be uploaded. Here we have the exponential equation, which is 9 raised to power y minus 2 divided by 81 raised to power y plus 1 equals to 728. So here we're told to find the value of y. We can deal with this part and this part. We want this part, and this part to have the same base, which is 9. We know 81 is 9 power 2, 729. This is 9 raised to power 3. So we can proceed as follows. Nine raised to power y minus 2 divide. Here, instead of writing 81, we write 9 raised to power 2 in the bracket y plus 1. Equals to, here we write 9 raised to power 3. Because 9 times 9 times 9, the answer is 728. Okay. Here, let's open the bracket. We are going to use the power rule, which is a power m in the bracket power n. This is equals to a power m times n. So we have 9 raised to power y minus 2 divided by, so we have 2 times y, we get 2y plus 2 times 1, we get 2 equals to 9 raised to power 3. So here the base is 9, the base is 9, but we have division sign. So in this case, the quotient rule of exponent will be used, which is a raised to power m divided by a raised to power n. This is equals to a raised to power m minus n. So let us apply the quotient rule of exponent in the left hand side of the equation. So we have 9 power y minus 2 minus, in the bracket, 2y plus 2 equals to 9 raised to power 3. Let us open the bracket here. We have 9 raised to y minus 2 minus 2y minus 2. This is equals to 9 raised to power 3. Collect like term. We have 9 raised to power y minus 2y minus 2 minus 2. This is equal to 9 raised to power 3. 9 y minus 2y, we get negative y. Minus 2 minus 2, we get minus 4, equals to 9 raised to power y. As you can see here, the base is 9, here the base is 9. Since the base of left hand side equals to the base of right hand side expressions, now we can equate the exponents. So we have negative y minus 4 equals to 3. Then shift this negative 4 to the right hand side. We get negative y equals to 3 plus 4. It is plus because in this side has negative sign. Once it shifts to the other side, which is the left hand side, it acquires the positive sign. So we have negative y equals to 7. Then divide by negative 1 both sides. We have negative y divided by negative 1 equals to 7 divided by negative 1. We get y equals to negative 7. This is the value of y. The value of y is negative 7. Please don't forget to subscribe, like, and share my video. Thank you. Once again, welcome to my YouTube channel known as Brother Nkoma J. With me, as you can see here, we have the exponential equation, which is root 7 raised to power root n minus root 5 raised to root n equals 24. And here we're told to solve for n, to find the value of n. Okay, let us proceed as follows. Solution. We know root a. This is the same as to write a raised to power a half. This is the law of radical fractional exponents. So let us apply this law of radical in here in root 7 and root 5. So instead of writing root 7 here, let us express it in the form of 7 raised to power a half in the bracket raised to radical n minus 5 raised to power a half in the bracket raised to root n equals to 24. Applying this law of exponent, which is a raised to power m in the bracket raised to power n, this is the same as to write a raised to power m times n. So in our case here, we are going to multiply these exponents. So we have 7 raised to power root n over 2, because a half times root n equals to root n over 2 minus 5 raised to n radical n over 2, because a half times radical n or root n equals to root n over 2, which is equal to 24. Rate u equals to radical n over 2. So instead of writing radical n over 2 here, so we have 7 raised to power u minus 5 raised to power u. This is equals to 24. As I've said let u equals to radical n over 2. So we substitute u in radical n over 2. That's why here we have 7 raised to power u and 5 raised to power u equals to 24. In our case here, the left hand side expression here and here raised to power 2 over 2. So we have 7 raised to power u in the bracket raised to 2 over 2 over 5 raised to power u in the bracket raised to power 2 over 2 equals to 24. The question is why do we raise this expression and this expression both to power 2 over 2? It is because we want to express the left-hand side as the difference of two squares. So here we have, in our case here, we now have 7 u over 2 in the bracket raised to 2 minus 5 raised to u over 2 in the bracket, 2 is outside, equals to 24. Okay. In our case here, we have the difference of two squares, but in a convenient way, also let x equals to 7 raised to power u over 2 and y equals to 5 raised to u over 2. So here, instead of writing 7 raised to power u over 2, we are going to write x. Again here, instead of writing 5 raised to u over 2, we are going to write y. So now the left-hand side expression becomes as x squared minus y squared equals to 24. This is the difference of two squares and can be factorized as follows: as x plus y in the bracket x minus y equals to 24. In this case here, we have used the method of factorization, which is known as the difference of two squares, which is a squared minus b squared equals to a plus b in the bracket a minus b. That's why this expression is written in this form. So in our case here, 24, this is 2 times 12. 2 times 12, we get 24. Bear it in mind, in our case here, x plus y should be greater or equal to x minus y. That is, the value of x plus y should be 12 because this one is greater. As you can see, 12 is greater than 2. The value of x minus y should be 2 because 2 is less than 12. So here we have the first equation is x plus y equals to 12 and x minus y equals to 2. This is the first equation, and this is the second equation. So, solving these two equations simultaneously, we have here plus sign. We have x plus x, we get 2x. Here, plus y minus y cancel each other once they are added. So we remain with 0. So we have 2x equals to 12 plus 2. This is 14. Divide by 2 both sides in order to get x. Divide by 2 both sides in order to get the value of x. So we have 14 divided by 2. We get x equals to 7. Substitute the value of x in equation 1. Substitute x equals to 7 in equation 1. So we get 7 plus y equals to 12. This is equation 1. X plus y equals 12. So in x here, we put 7. That's why you see 7 here. Plus this one, y, which is this one, equals to 12, this one. So we have y equals to 12 minus 7. So 12 minus 7, we get 5. Okay, we have x equals to 7 and y equals to 5. But we are not taught to find the value of x and y. Recall here, we said let x equals to 7 raised to power u over 2 and y equals to 5 raised to u power 2. So substitute the value of x and y here and here. So we have x which is 7 equals to 7 raised to here u over 2 raised to u over 2, and in this case here y equals to 5 raised to u over 2, but y equals to 5. So we have 5 equals to 5 raised to u over 2. Put power 1 here and power 1 here. As you can see, they have the same base. So compare the exponents. So we have 1 equals to u over 2. So u over 2 equals to 1. Multiply by 2 both sides. So we have 2 times u over 2 equals to 2 times 1, which is, we get u equals to 2. Even in this case, we are going to get u as 2. Let us proceed. We have 1 equals to u over 2. Obvious again here, we have u over 2 equals to 1. Multiplying by 2 both sides, again here we get u equals to 2. So therefore, u equals to 2. Again, we have u equals to 2. But recall here, where we said let u equals to root n over 2. So we have u, but u equals to root n over 2. Substitute the value of u, which is 2 here. So we have 2 equals to root n over 2. Multiply by 2 both sides. We have 2 times 2 equals to radical n or root n over 2 times 2. So we have 4 equals to root n. So root n equals to 4. Taking square both sides, we have radical n power 2 and 4 power 2. So these two cancel with this radical sign. We remain with n equals to 4 times 4. We know 4 raised to 2. Our 4 squared equals to 4 times 4. So n equals to 16. This is our answer. Please don't forget to subscribe, like, share, and comment. Thank you. Let us verify whether it's true or not that n equals to 16 in our equation, which is 7 root 7 raised to root n minus root 5 raised to root n, whether it's true or not. That is equals to 24. Substitute the value of n equals to 16 in our case here. We have radical 7, then radical o root 16 minus root 5. Again here we have root 16 equals to 24. We know square root of 16. This is the same as 4, taking the positive value. Again here, we know square root of 16 equals to 4. This is equals to 24. We know root 7 or radical 7, this is the same as to write 7 raised to power a half in the bracket equals to 4 minus root 5, this is the same as to write 5 raised to power a half in the brackets times 4 equals to 24. So here we know a half times 4, this is as 7 squared. Here we have 5. A half times 4, we get 2 equals to 24. 7 raised to power 2, this is 7 times 7, this is equals to 49 minus 5 raised to power 2, this is 5. This is 5 times 5, which is 25, equals to 24. So 49 minus 25, the answer is 24, sorry. As you can see here, 24 equals to 24. Therefore, the answer is correct. Please don't forget to like, comment, and share my video. Thank you. Welcome to my YouTube channel known as Brother Nkoma J. With me is the exponential equation. In these exponential equations, we are supposed to find the value of y. As you can see here, in order to get the value of y, first factor out 3 raised to power y. In so doing here, we have 3 raised to power y. Here, we remain with 1 plus 1 in the bracket equals to 18. 1 plus 1 equals to 2. So we have 3 raised to power y times 2 equals to 18. Okay. In our case here, divided by 2 both sides. We have 3 raised to power y times 2 over 2 equals to 18 divided by 2. So here, this 2 cancels this 2, will remain with y, will remain with 3 raised to power y equals to 18 divided by 2. The answer is 9. We know we want this 3 also to appear in here. That is, we want both sides to have the same base. So what can we do? Here, write this 9 as 3 raised to power 2. So we have 3 raised to power y. This is equals to, instead of writing 9, we can write 3 raised to power 2. Because 3 power 2, the answer is 9. As you can see here, both they have the same base. What we can do here is to equate or compare the exponents. Comparing the exponents, we find that y equals to 2. This is our answer. We can prove it whether it is true or not. Verify. Let us verify. We have 3 power y plus 3 power y equals to 18. But the value of y here is 2. So we have 3 power 2 plus 3 power 2 equals to 18. 3 power 2 is 9. Again here 3 power 2 is 9. So we have 9 plus 9, which is equal to 18. 9 plus 9 is 18. So we find that 18 equals to 18. So the value of y, which is equal to 2, is true. Please don't forget to like, share, comment, and subscribe. Thank you. Once again, welcome to my YouTube channel known as Science Math with Brother J. Here we have the exponential equation, which is 3x raised to the power x plus 1 plus 3x raised to power x is equal to 30x. Here we are supposed to find the value of x. We are told to find the value of x. In order to get the value of x, let us deal with this part of the equation. Here, in order to deal with this part of the equation, let us use the law of exponent, which is the product rule. It says that a raised to power m times a raised to power n, this is equals to a raised to power m plus n. As you can see here, this expression resembles this part of the law. So using this law, we want to express this expression in this form using this law of exponent, which is the product rule. So here we have 3 raised to power x times 3 raised to power 1 plus 3 raised to power x equals to 36. So we have 3 raised to power x. Once again, welcome to my YouTube channel known as Science Math with Brother J. Please don't forget to subscribe, like, and share my video. Here we have been given a question. As you can see, if 2 power n equals to 3, now we are told to find the value of 16 raised to power n times 4 raised to power n plus 2 over 64 raised to 2 n. So in order to get the value of this expression, what we can do is to break this one, and this one, so that we can get 2 raised to n. We know 16 is 2 power 4. So we have 2 power 4 in the bracket raised to power n times 4, it is 2 raised to power 2. So we have 2 raised to power 2 in the bracket, n plus 2 over 64. This is 2 raised to power 6 in the bracket raised to 2n. Okay, now we can open the brackets here by multiplying 2 times n, 2 times 2, by using the law of exponent, which says that a power m in the bracket raised to n, this is equals to a raised to m times n. So let's open the bracket here. We have 2 raised to power 4 in the bracket times 2 raised to 2n plus 4. 2 times n, the answer is 2. 2 times 2, the answer is 4. Over 2. Again here, we have 6 times 2n. We get 12n. Again here, we can use the law of exponent, which is the product rule. It says like this: a power m times a power n. This is equals to a power m plus n. So this expression is in this form. We want to change it in this form. So we have 2 power 4. Sorry, here we have n in the bracket raised to power n times 2 raised to power 2n times 2 raised to power 4 over 2. This one can be written as 2 raised to power 12 in the bracket power n. Even this one can be written in this form. Now here we can exchange the exponents. Exchange the exponents by using the following law of exponent, which is the power rule. A power m in the bracket power n. This is the same as to write a power n in the bracket power n. The matter of exchanging the exponents. The same applies here. 4 goes outside and the n goes inside. So we have 2 power n in the bracket power 4 times 2 power n in the bracket power 2 times, we know 2 power 4, this is 16, over 2 power n in the bracket power 12. But But 2 power n equals to 3. So here we are going to substitute 3. Even this 2 power n here we are going to substitute 3. And here we are going to substitute 3. So we have 3 power 4 times 3 power 2 times 16. Sorry. Times 16 over 3 power 12. As you can see, instead of writing 2 power n, we have written 3 power 4. Here, 3 power n power 2, we have written 3 power 2 times 16 over. Here, we have written 3, and here we have 12, the exponent. As you can see here, we have 12 as exponents. Again here, we can apply the product rule of the exponents. So we have 3 power 4 plus 2 times 16 over 3 power 12. Here we get 3 raised to power 6 times 16 over 3 raised to 12. Again here, we can use the quotient rule of exponent, which is a raised to power m divided by a raised to power n. This is equals to a raised to power m minus n. So we have 3 raised to power 6 minus 12 times 16. So here we have 6 minus 12, we get negative 6. 3 raised to power negative 6 times 16. Again here, we can use the law of the exponent, which is the negative exponents. A power negative 1 equals to 1 over a power negative n. So we have 1 over 3 power 6 times 16. We know 3 power 16 is 729 times 16. So here we get 16 over 729. This is our answer. Please don't forget to subscribe, share, and like my video. Thank you. Welcome to my YouTube channel known as Brother Nkoma J. With me here is an exponential expression. Here we are told to simplify it. In order to simplify this an exponential expression, first of all, let us express the denominator in the form of the difference of two squares. Okay? We have 3 raised to power x minus 1 over, here we have 9. 9 is 3 raised to power 2. So instead of writing 9 here, let's write 3 raised to power 2 in the bracket raised to power x minus 1. Okay, applying the rules of exponents, which is a raised to power m in the bracket raised to power n. This is the same as to write a raised to power n in the bracket raised to power m. As you can see here, the exponents, we are just interchanging the exponents. The one which is inside goes outside, the one which is outside goes inside. So let's apply this row of exponent in this part. So here we are going to interchange x and 2. 2 will go outside and x inside. So we have 3 raised to power x minus 1 over 3 raised to power x in the bracket raised to power 2 minus 1. This is the difference of 2 square. We can write it as 3 raised to power x minus 1 over 3 raised to power x raised to power 2 minus 1 raised to power 2. We know 1 power 2, the answer is 1. So let us factorize it in the form of difference of 2 squares. That is, we know a squared minus b squared. This is factorized as a plus b in the bracket a minus b in the bracket. So the same factorization method, which is the difference of 2 squares, will be applied here. Our a is 3 raised to power x, and b equals to 1. So now let us apply this rule here in the denominator. So we have 3 raised to power x minus 1 over 3 raised to power x plus 1 in the bracket, then 3 raised to power x minus 1 in the bracket. Obvious, in this case, we find that this one cancels with this one. So therefore, we remain with 1 over 3 raised to power x plus 1. This is our answer. Thank you. Please don't forget to subscribe, like, and share my video. Once again, welcome to my YouTube channel known as Science Math with Brother J. As you can see here, we have the exponential equations. As you can see, now we're told to express the exponential equation in terms of k, given that k equals to 3 raised to power x, and thereafter we are told to solve for x. Let's go. Here is our exponential equation. So let us proceed as follows. We are going to use the laws of exponents to express this exponential equation in terms of k. Starting with the first part. Thereafter, we are going to continue with the second part. We know a raised to m divided by a raised to n. This is equals to a raised to m minus n. This is the quotient rule of exponent. Yeah, in this question, this rule will be used. As you can see, this one is in the form of this one. So we are going to change this form, which is in this form, to this form. So we know this is the same as to write 3 raised to power 2x divided by 3 raised to 1 minus 4 times, again here, this law of exponents will be used. So we have 3 raised to x divided by 3 raised to 1 equals to negative 1. Okay, this one is the same as to write 3 raised to 2 power x over 3 minus 4 times 3 raised to power x over 3 divided is represented by this line, which is has the same meaning as to divide. The same applies to here. Instead of writing this sign, we have written over, which is the same as divide by, equals to negative 1. So again here, we can use this law of exponent, which is a raised to power m in the bracket raised to n. This is the same as to write a raised to power n in the bracket raised to power m. We just interchange the exponent here. The one which is outside goes inside, and the one which is inside goes outside. So the same applies to here. Applies using this law of exponents. 3 raised to 2 power 3 raised to 2x can be written as 3 raised to x in the bracket raised to 2 over 3 minus, this is the same as to write 4 over 3 times 3 raised to power x equals to -1. But here we are told k equals to 3 raised to x. So, but 3 raised to power x equals to k. So, wherever there is 3 raised to power x, we are going to substitute k. Because in our question, we've been told that 3 raised to power x equals to k. So here, instead of writing 3 raised to x, we are going to write k. The same here, instead of writing 3 raised to x, we are going to write k. So we have k squared over 3 minus 4 over 3. Again here, substitute k. So we have 4k, which is equal to -1. Multiply by 3 throughout. So we have 3 times k squared over 3 minus 4 over 3 k times 3 equals to -1 times 3. So here, this 3 cancels this one, this 3 cancels this one. The same, this 3 cancels this one. Here we remain with k squared minus 4k equals to -3. Okay. Shift this -3 to this side. So we have k squared minus 4k plus 3 equals to 0. Here we have already expressed the exponential equation above in terms of k. But we are told to find the value of x. In order to find the value of x, first find the value of k. Thereafter, find the value of x. This is a quadratic equation. Let's use the splitting the middle term methods to solve this quadratic equation. We are supposed to find two numbers or two factors. Once we add them, we get -4. The same numbers, once are multiplied, we get positive 3. These numbers are negative 3 and negative 1. So we have k squared minus 3k minus k plus 3 equals to 0. Factor out k. Here we have k. Outside, inside we remain with k. And here we remain with 3. Again here, factor out 1. Here we have k. Here we have negative 3 in the bracket equals to 0. So we have k minus 1 in the bracket. Here we have k minus 3 equals to 0. We have taken this k and negative 1, which is this one, and then we have taken one of these because they are the same. That's what we have written here. From this, now we can say either k minus 1 equals to 0 or k minus 3 equals to 0. Shift negative 1 to the right hand side, we get k equals to 1, or again here, shift negative 3k to the right hand side, we get k equals to positive 3. So k equals to 1 or 3. Bear it in mind, we are not taught to find the value of k or to solve for k, but we are rather taught to solve for x. Remember, above there, we are told that, but k equals to 3 power x. So here we are going to substitute the value of k equals to 1 here, which is 1 equals to 3 raised to power x. Again, the value of k equals to 3 here. So we will get 3 equals to 3 raised to power x. So now we have 3x equals to k. Our k is 1. Or 3 power x equals to 3. So this one is the same as to write 3 raised to power x. Instead of writing 1 here, we write 3 raised to power 0 using the law of exponent, which is 0 exponents. We know any number raised to power 0, the answer is what? 1. So this law is the one we use here. Instead of writing 1, we write 3 power 0. Why do we write 3 power 0? Because we want to make the base of the both sides to be equal so that we can equate the exponents. Because we have 3 here, so here, that's why I've written 3 power 0. Or we have 3 power x. This 3 is the same as to write 3 power 1. So from here, we can say, because we have base 3, just equate the exponents. So we have x equals to 0, or the same applies here, the base is 3, and here the base is 3. So we just equate the exponents. So again here we say x equals to 1. Therefore, x equals to 0 or 1. This is the value of x. Please don't forget to subscribe, like, and share my video. Thank you. Once again, welcome to my YouTube channel known as Brother Nkoma J. With me here, we have the expression, which is root 5 over y minus 1 equals to root y over 4. And here we are told to find the value of y. Let's go. Let's proceed as follows. Solution. We have root 5 over y minus 1. This is equals to root y over 4. In this case here, let us remove radical sign. How do we remove radical sign? Square both sides of the equation. So we have root 5 in the bracket squared over y minus 1 in the bracket squared equals to root y in the bracket squared over 4 squared. So in this case here, this 2 is going to cancel with this radical sign. So we remain with 5 over y minus 1 in the bracket squared. Again here, this 2 is going to cancel with the radical sign. We remain with y equals to 4 squared. This is 16. 4 squared equals to 4 times 4. Closing multiplication here. We have y in the bracket, y minus y in the bracket squared equals to 5 times 16. In our case here, we need not to multiply 5 times 16 because we're going to get the answer. But that answer, later on, we will be supposed to find the factors of that answer, which is almost 5 and 16. So leave the way it is. In our case here, what we are going to do is just to compare. That is, whether y equals to 16 or equals to 5. Which one among these ones satisfies the left-hand side expressions, starting with 5. If y equals to 5, is okay, but here, 5 minus 1, we get 4. 4 squared is 16. But it's quite different if we use y as 16 here. Obvious. Here we are going to have 16, but here we are going to have 16 minus 1, which is 5, which is 15. 15 squared, the answer is not 5. So obvious here, we have y equals to 5 or y minus 1 in the bracket squared equals to 16. What we do is just a comparison. We compare the left-hand side expression and the right-hand side expression. In our case here, y equals to 5, and this expression equals to 16. So we have y equals to 5, or here taking square root, equals to taking the positive value, square root of 16. So we have y equals to 5 or y minus 1 equals to square root of 16, which is 4. As you know, this radical sign cancels with this 2. So we have y equals to 5 or y equals to 4 plus 1. Shift this one to that side. It has negative sign. Once it shifts to the left hand side, it acquires the positive sign. So we have y equals to 5. We can also verify if the answer is true or not. So in our expression, we have root 5. Root 5 over y is 5, minus 1 equals to root y. Our y is 5 over 4. Okay. We have root 5. 5 minus 1, the answer is 4, equals to root 5 over 4. Since the left-hand side equals to right-hand side, therefore, the answer is true. The value of y is 5. 5 is the correct answer. Please don't forget to like, share, and comment in my video. Thank you. Once again, welcome to my YouTube channel known as Science Master with Brother J. Please don't forget to subscribe, like, share my video. Here we have the exponential equation, which is y raised to power 16 equals to 64 raised to y. So we are told to solve for y. So let us proceed as follows. Solution. First of all, let us copy the question the way it is. Which is y raised to power 16 equals to 64 raised to exponent y. Here, first of all, multiply both sides of the equation by the inverse of y. The inverse of y equals to 1 over y. This is sometimes known as reciprocal. So multiply 1 over y, both sides of the equation. So we have y raised to power 16 in the bracket 1 over y equals to 64 raised to power y in the bracket raised to 1 over y. So here we have y raised to power 16 in the bracket raised to 1 over y equals to 64. Okay, from this, let us deal with this part using the law of exponents, which is a raised to power m in the bracket raised to power n. This is the same as to write a raised to power n in the bracket raised to power m. We just interchange the exponent. The one which is inside goes outside, and the one which is outside go inside. So this is what we are going to apply here. 16 will go outside and 1 over y will go inside. So we have y raised to 1 power 1 over y in the bracket raised to power 16 equals to 64. We want to eliminate this 16. In order to eliminate this 16, we are going to raise to the power, which is the inverse of 16. Inverse of 16 equals to 1 over 16. So raise 1 over 16 to both sides of the equation. We have y raised to 1 power 1 over y in the bracket raised to exponent 16. In the bracket again raised to 1 reciprocal or inverse of 16, which is 1 over 16. This is equals to 64 raised to the exponent 1 over 16. So here we have y raised to exponent 1 over y equals to 64 raised to 1 exponent 1 over 16. We know 64. We want to express this side of the equation in this form. The number which is here should also be available here. The same as we can see here. Here we have y, here we have y. So we want to express 64 raised to 1 over 16 in this form. So we know y raised to 1 over y equals to 64. This is 8 raised to power 2 in the bracket raised to 1 over 16. Again, here we have y raised to 1 or 1 over y raised to exponent y over y equals to 8. We know 2 cancels with this 16. By 2, 1. By 2, 8. So here we have 1 over 8. Now, as you can see, this has the same form as this one, or rather, this one has the same form as this one. They resemble each other. We have y raised to 1 over y. Here we have 8 raised to 1 over y. So from this, we can equate whether 1 over y equals to 1 over 8. Here we have equated the exponents. The same, we can equate the bases. Y equals to 8. Which one is simple? The simplest one is to equate the base. So from this, we have y equals to 8. This is our answer. Please don't forget to subscribe, like, and share my video. Thank you. Welcome to my YouTube channel known as Science Math with Brother J. Please don't forget to subscribe, like, and share my video. As you can see here, we have the exponential equation, which is 5 raised to power x raised to 2 minus 3 equals to 125 raised to 2. So if we look at base 5 and base 125, we find that 125 can be converted, or rather changed, to base 5, since 3 raised to power 3 equals to 125. So we can proceed as follows. We have 5 raised to x raised to 2 minus 3. This is equals to, so instead of writing 125, so we write 5 raised to power 3 in the bracket power 2. We know 5 raised to 3, this is equals to 5 times 5 times 5, which is equal to 125. So that's why here we have written 5 raised to power 3, which is equal to 125. So here, in this side, we are going to use the law of exponent, which is the product rule, which states that a raised to power m in the bracket raised to n, this is equals to a raised to power m times n. So here our m is 3 and our n is 2. So we are going to multiply 3 times 2, which is 6. So here we are going to write 5 raised to x raised to 2 minus 3. This is equals to 5 raised to 6, because 3 exponent 3 times exponent 2, we get 6. From here, as we can see, both they have base 5. Here the base is 5 and here the base is 5. We can equate the exponents as follows. So we have x raised to 2 minus 3. This is equals to 6. Then shift this 6 from the left hand side to right hand side. We have x raised to 2 minus 3 minus 6 equals to 0. Because once we shift positive 6 to the left hand side, its sign is going to change. That's why here we have negative 6. Here we have x raised to 2 minus 9, because negative 3 minus 6, we get negative 9, which is equal to 0. This exponential equation can be written as x raised to 2 minus 9 is the same as to write 3 power 2 equals to 0. This one is the difference of two squares. We have x squared minus 3 squared. We can use this identity, which is x, which is a squared minus b squared equals to a plus b in the bracket a minus b. So we are using these methods of factorization known as the difference of two squares to factorize this expression in the left hand side. We know in our case here, a equals to x and b equals to 3. So we have x plus 3 in the bracket, then you have x minus 3 in the bracket equals to 0. Here, either x plus 3 equals to 0, or x minus 3 equals to 0. So shift this to the left hand side. We have x equals to 3 or x equals to positive 3. Here we have negative 3 because once this 3, positive 3, is shifted to the left-hand side, is going to acquire the negative sign. The same applies to this negative 3. When we shift it to the right-hand side, is going to acquire positive sign because it has negative sign. So therefore, x equals to negative 3 or positive 3. This is the solution of our exponential equation. Please don't forget to subscribe, like, and share my video. Thank you. Welcome to my YouTube channel known as Science Math with Brother J. Please don't forget to subscribe, like, and share my video. As we can see here, we are told that 3x minus y equals to 5. And now we want to find the value of 27 raised to power x over 3 raised to power y. So we can proceed as follows. (27 raised to power x over 3 raised to power y. This is the same as to write 27 raised to power x times 1 over 3 raised to power y. Okay, let us proceed. We have 27 raised to power x times 3 raised to power negative y. Here we use the law of the exponent, which is the negative exponent law. It says like that: a power negative 1. This is equals to 1 over a power n. So we have 1 over 3 power y, which is in this form. So we want to change it to this form. That's why this one is written in this form by using this law of exponent, which is the negative exponents. So we can proceed as follows. We know 27 is 3 raised to power 3. So instead of writing 27, we write 3 raised to power 3 in the bracket raised to x times 3 raised to power negative y. So here, let us multiply the exponents by using the following law of exponent, which is the power rule. It says like this: a raised to m in the bracket raised to n. This is equals to a raised to m times n. So we are going to use this rule here, the matter of multiplying the exponents, 3 times x. So we have 3 raised to 3x times y raised to power times 3 raised to power y. Again here, you can see the base here is 3 and here the base is 3. So by using the law of exponents, we add the exponents if the base are equal, provided that here there is multiplication sign. We use the product rule, which states that a power m times a power n. This is the same as equals to a power m plus n. So this is the law we are going to use. So we have 3 raised to power 3x plus negative y. As you can see here, we have a raised to power m times a raised to power n. This is equals to a raised to m plus n. The same, we can apply this rule here. The same base, add the exponents. So we have 3 raised to power 3x minus y. But in our question, we have been given 3x minus y equals to 5. So here we are going to substitute 5. Instead of writing 3x minus y, you're going to write 5 here. So we have 3 raised to power 5. 3 raised to power 5. This is the same as to write 3 times 3 times 3 times 3 times 3, which is equal to 243. This is our answer. Please don't forget to subscribe, like and share my video, and turn the notification bell so that you can be the first to get my video once will be uploaded. Once again, welcome to my YouTube channel known as Brother Nkoma J. With me is an exponential equation, which is 9 raised to power m minus 7 raised to power m equals to 32. So now we are told to find the value of m. In order to get the value of m, the first step which we are supposed to go about is to express the left-hand side as the difference of two squares to express the left-hand side in the form of the difference of two squares. How can we do? Here, take this one, which is 9 raised to power m, put it in the bracket, and then raised to 2 over 2, because 2 over 2 is 1. 1 times m, the answer is m. So we have not changed anything. This is just the manipulation. Minus 7 raised to m in the bracket raised to 2 over 2 equals to 32. Again here, this one is the same as this one, because 2 over 2 is 1. 1 times m, we get m. In our case here, we're going to use this law of exponent, which is a power m in the bracket raised to power n. This is the same as a raised to power m times n. So let us multiply m times 2 over 2. M times 2 over 2. This one can be written as 9 raised to m over 2 in the bracket. This 2 remains outside. Minus 7 raised to power m over 2, while this 2 remains outside, equals to 32. Here, rate x equals to 9 raised to m power 2 and y equals to 7 raised to m over 2. So substitute x here and y here. So we have x squared minus y squared equals to 32. This is the difference of two squares. How is it factorized? The difference of two squares is factorized as, for example here, we have a squared minus b squared. This is equals to a plus b in the bracket a minus b. So we have x plus y in the bracket x minus y in the bracket equals to 32. 32, this is 2 times 16. 2 and 16 are the factors of 32. As you know, in this case here, x plus y should be greater or equal to x minus y. So we have x plus y, this is equals to 16, because 16 is greater than 2. And x minus y, this is equals to 2. This is question number 1. And this is question number 2. Solving equation 1 and 2 simultaneously, we get, here we add because this is positive and this is negative. So x plus x, we get 2x. Positive y, negative y, once they added, they cancel each other. So here we remain with 0. 16 plus 2, the answer is 8. The answer is 18. Divided by 2 both sides. 2 divided by 2, 18 divided by 2. 18. These 2 cancel with this one. We remain with x equals to 18 divided by 2. We get 9. Substitute the value of x in equation 1. Substitute x equals to 9 in equation 1. In equation 1 or 2. Let us use equation 1. So we have x, which is 9, plus y equals to 16. So we have y equals to 16 minus 9. 16 minus 9, we get y equals to 7. Bear it in mind, we have not been told to find the value of x and y. We are told to find the value of m, as you can see here. But bear it in mind, here we say that let x equals to 9 raised to m over 2 and y equals to 7 raised to m over 2. So substitute the value of x here and substitute the value of y here. So we have x, which is 9. 9 equals to 9 raised to power m over 2. And y, the value of y is 7, equals to 7 raised to m over 2. We get this one from here. Here we have written 9, and here we have written 7. That is what you see here. This is the same as to write 9 power 1 equals to 9 raised to power m over 2. And this one is the same as to write 7 raised to power 1 equals to 7 raised to m over 2. Since they have the same base, compare the exponents. So we have m over 2 equals to 1 and m over 2 equals to 1. Multiplying by 2 both sides. 2 times m over 2 equals to 2 times 1 and 2 times m over 2 equals to 2 times 1. These 2 cancel with this, will remain with m equals to 2 times 1, which is 2. The same applies here. We're going to get m is 2. Verify. Let us verify if it's true that m equals to 2. Substitute the value of m in the equation, which is 9 raised to power m minus 7 raised to power m equals to 32. In our case here, we have 9 raised to power 2 minus 7 raised to power 2 equals to 32. 9 times 9, this is 81, minus 7 times 7, this is 49, is equal to 32. 81 minus 49, the answer is 32, which is equal to 32. since the left hand side equals to the right hand side, therefore m is true, which is equal to 2. Please don't forget to subscribe, like, and share my video. Thank you. Welcome to my YouTube channel known as Brother Nkoma J. With me, we have an equation here. In this equation, we are told to find the value of y. So let's go. Solution. Let's see the solution of this equation. First, copy the equation the way it is. We have 3 raised to power y over 6 plus 3 raised to power y. This is equals to 3 over 5. In this case here, the first step is cross multiplication. So in so doing, we have 5 times 3 raised to power y. 5 in the bracket, 3 raised to power y equals to 3 in the bracket 6 plus 3 raised to power y. Open the bracket. In the right hand side we have 5 in the bracket 3 raised to power y equals to 3 times 6, you get 18, plus 3 times 3 raised to power y, we have 3 in the bracket 3 raised to power y. Okay, here collect the like term. This is the same as this term is the same as you can see. This is 3 raised to power y, this is 3 raised to power y. They are like terms. So let us put them together. Shift this term to the left hand side. We have 5 in the bracket 3 raised to power y minus 3 in the bracket 3 raised to power y. This is equals to 18. As you can see here, 3 raised to power y, 3 raised to power y is common. So you can factor out. Just factor out 3 raised to power y. In so doing, we have 5 minus 3 in the bracket 3 raised to power y. Take out of the bracket 3 raised to power y. So here, if you take 3 raised to power y, we remain with 5 again. Here, if you take 3 raised to power y out of the bracket, we remain with 3. This one equals to 18. 5, take away 3. We have 2. In the bracket, 3 raised to power y equals to 18. Here, divide by 2 both sides. we have 2 over 2 in the bracket 3 raised to power y equals to 18 divided by 2. So this 2 cancels with this one. So we'll remain with 3 raised to power y equals to 18 divided by 2 equals to 9. We want to express 3 with the base. So we want to express this 9 in the form of 3 raised to power 2. So we have 3y equals to 9. This is the same as to write 3 raised to power 2. As you can see here, the base of the left hand side equals to the base of the right hand side. So since these bases are equal, what we can do is to compare their exponents. So in this case, we have y equals to 2. This is our answer. We can even prove if it is true or not. As you know, our equation is, let us verify in 3 raised to y over 6 plus 3 raised to y equals to 3 over 5. So in our case here, substitute the value of y equals to 2. We have 3 raised to power 2 over 6 plus 3 raised to power 2 equals to 3 over 5. We know 3 raised to power 2, this is equals to 9 over 6 plus 3 raised to power 2, this is 9 equals to 3 over 5. In our case here, we have 9 over 15 equals to 3 over 5. We can simplify. We have 9 over 15 equals to 3 over 5. By 3, we get 3. By 3, we get 5. So we find that the left-hand side equals to the right-hand side. So therefore, this is the correct answer. Thank you for watching my video. Please don't forget to subscribe, share, and comment. Welcome to my YouTube channel known as Science Maths with Brother J. Once again, we have an exponential equation which is 27 raised to power x plus 3 raised to power x equals to 738. we are told to find the value of x. So here we are going to express 27 as 3 power 3 in the bracket raised to x plus 3 raised to x equals to 738. Here we can interchange the exponents. The x goes inside and 3 goes outside by using this law of exponent, which is a power m in the bracket power n. This is the same as to write a power n in the bracket power m. So the same rule will be used here. So here we can write 3 power x in the bracket power 3 plus 3 power x equals to 738. Then shift 738 to this side. We have 3 raised to power x in the bracket raised to power 3 plus 3 raised to x minus 738 equals to 0. Thereafter, find a number which is near to 738, but that number can be expressed as a cube root of as a cube of a certain number. Find the number which is near to this, but that number can be expressed as a cube of certain number. In our case, we have here we are going to write 3 raised to power x as usual plus 3 raised to x. So here we have 729. 729, this is 9 power 3, or 9 raised to 3, or 9 cubic, minus 9 equals to 0. We know 727, negative 727 minus 9, this is equals to 700, negative 738. So what is supposed to be done here is to break this number so that we get two numbers. One of it can be expressed as a cubic of certain number. As I've said, 728, this is 9 power 3. Okay? Thereafter here, let 3 raised to x equals to k. So here instead of writing 3 power x, we are going to substitute k. And here, instead of writing 3 raised to x, we are going to substitute k. So we have k raised to 3 plus k minus 729 minus 9 equals to 0. So this one can be rearranged as follows. We can write k raised to power 3 minus 729 plus k minus 9. This is equals to 0. As I've said, 729, this is 9 raised to power 3. So here we are going to write k cubic minus 9 cubic. Because 9 cubic, this is equals to 729 plus k minus 9 equals to 0. In this case, we are going to use the following expansion, which is a cubic. Apply. A cubic minus b cubic. This is the same as to write a minus b in the bracket, again in the bracket, a squared plus ab plus b squared. So we have, in our case here, a equals to k and b equals to 9. So we are going to apply this expression in our case here. So we have k minus 9 in the bracket, which is this one. In the bracket, we have a squared. So here we are going to write k squared plus a. In our case, a is k times b. B is 9. Then plus b squared. B is 9, so we have 9 squared in the bracket. Then we are going to write this expression. This one, we get this one. Plus k minus 9. This is equals to 0. So we have k minus 9 in the bracket, k squared plus k times 9, we get 9k. 9 squared, this is 81. Plus, here we can just write k minus 9 equals to 0. As you can see, k minus 9, it is common to here and here. So we can factor out k minus 9. Factor out k minus 9. We get k minus 9 in the brackets. Again, here, if we factor out k minus 9 here, we are going to remain with k squared plus 9k, this is 81, sorry, because 9 squared is 81, plus 81 plus, here, if we factor out k minus 9, we are going to remain with 1 in the bracket equals to 0. So we have k minus 9 in the bracket, k squared plus 9k plus 81 plus 1, we get 82 equals to 0. So here we can say either k minus 9, this is equals to 0, or k squared plus 9k plus 82, this is equals to 0. So in this side, shift negative 9 to that side, we have k equals to 9, or k squared plus 9k plus 82k equals to 0. This is a quadratic equation. We know a equals to 1, that is the value of a, b equals to 9, and c equals to 82. Applying the formula, which is the quadratic formula, b squared plus or minus under root, we have, this is equals to negative b plus or minus under root b squared minus 4ac over 2a. This is the quadratic formula. Substituting the value of a, b, and c in our formula, we have negative 9 plus or minus under root 9 squared minus 4 times a equals to 1, times c equals to 82. Over 2 times a. A is 1, so it is times 1. Okay, here we get negative 9 plus or minus under root 81 minus 4 times 1 times 82. We get 328 over 2. So we have negative 9 plus or minus under root 81 minus 328. This is equals to negative 247 over 2. Since root negative 24/7, the square root of negative 247, this one has no real roots, then k is going to remain equals to 9, the one we got here. This part we have ended that it has no root. As you can see, because it's negative, it has no real root. So the only value of k is 9. Remember, we are not told to find the value of k. We are rather told to find the value of x. Remember, somewhere we said that let 3 power x equals to k. We said let 3 power x is equal to k. So we have 3 power x equals to k, somewhere there. But the value of k is 9. So we have 3 raised to x equals to 9, which is the value of k. So here we have 3 raised to x (9). This is 3 raised to 2. Since they have the same base, we are going to equate the exponents. This is base 3 and this is base 3. Obvious. X equals to 2. X equals to 2. This is the value of k. As we have seen there, the other side has no real roots. So the only value of k we got, it was 9, and 9 through 9 we get the value of x equals to 2 by equating, by letting 3 raised to x is equal to k and k equals to 9. As we have seen here, we have reached that the value of x equals to 2. Please don't forget to subscribe, share, and like my video. Thank you. Welcome to my YouTube channel. Please don't forget to subscribe, like, and share my video. As you can see here, we have the following expression, which is 3 power 7 minus 3 power 5 plus 16 over 3 power 5 plus 2. Here we are supposed to simplify these expressions. So in order to simplify this expression, what we are supposed to do is first to break this 3 power 7 so that we can get 3 power 5 times other factor. So 3 power 7, this is the same as to write 3 power 5 times 3 power 2. Because we know this one, its base is 3, and this one, its base is 3. Since they have the same base, as we know, by using the product rule of exponents, we know if two factors they have the same base, what we do is only we add the exponent. We know 5 plus 2, the answer is 7. So that's why here we have written 3 power 5 times 3 power 2, because we know 3 power 5 times 3 power 2, this is equals to 3 power 7 by adding the exponents. Minus 3 power 5 plus 16 over 3 power 5 plus 2. Here we are going to factor out 3 power 5 because 3 power 5 appears here and again it appears here. So we are going to factor out 3 power 5. So we have 3 power 5 in the bracket. Once we factor out 3 power 5 here we remain with 3 power 2 minus, here we are going to remain with the 1 because the one which we have factored out is the same as the one which appears here. So here we are going to remain with 1 plus 16 over 3 power 5 plus 2. Here we are going to deal with the 1 inside the bracket. We know 3 power 2, this is the same as 3 times 3, which is equal to 9. So here, instead of writing 3 power 2, we are going to write 9. So we have 3 power 5 in the bracket, 9 minus 1 in the bracket, plus 16 over 3 power 5 plus 2. Nine minus 1, the answer is 8. So we are going to write 3 power 5 in the bracket, we have 8 because we know 9 minus 1, the answer is 8, plus 16 over 3 power 5 plus 2. We know 16 is 2 times 8. So instead of writing 16 here, we are going to write 2 times 8. So our expression will be like this: 3 power 5 in the bracket, 8 plus 16 is 8 times 2 over 3 power 5 plus 2. Here we have 8, here we have 8. We can factor out 8. So we have 8 in the bracket, 3 power 5 plus, here we are going to remain with 2 because already 8 is outside, over 3 power 5 plus 2. As you can see here we have 3 power 5 plus 2, and here in the denominator we have 3 power 5 plus 2. The one in the numerator is going to cancel with the one in the denominator. So this one is going to cancel with this one. So we are going to remain with 8. This is the answer for the expression above. Please don't forget to subscribe, like, and share my video. Thank you for watching.